Hello, my name is Devashish Sood and this is my explanation video for Honors Problem 4, where I will go through explaining steps for certain instructions that are passed on to binary search trees and skip lists. In this case, we begin by the instruction insert 10, and so it begins by looking at the tree. Since 20, the value stored at the very top node, is greater than 10, it knows that 10 must be placed in the left subtree of 20, and so it traverses the left subtree, which is empty, returning a nil, and therefore it knows that 10 must be placed right there, and that is where 10 ends up being placed. In the skip list, what ends up happening is that in the very topmost list, it compares the value 10 against the first express stop, the 20 and negative infinity, realizes that it's greater than negative infinity but less than 20, so it moves on to the next list, which once again has 20 and negative infinity, and then moves on to the last list, which and realizes that the value 10 must be placed between 10, 20 and negative infinity. And so, since we are also using a randomized coin flip for this specific instruction, the coin flip that is given for 10 is 1 0, and that is why 10 is added to the list just above the bottommost list as well. For this specific instruction, which is in search 20, it begins by the very top of the tree where we have a 10, realizes that 20 is greater than 10, so it must be placed in the right subtree, moves on to the next value, which is 40. 20 is less than 40, so we realize that 20 must be placed in the left subtree of 40, and the next node that we receive is at 20. Now, now because 20 is equal to 20, this value can be placed on either side, and in this specific case, we've chosen to place it on the right. For the case of adding 20 to the skip list, we begin by the very topmost list, which is empty, move on to the second one, in which the bounds that are received are the fact that 20 is greater than 10 but is lesser than 100. So it moves on to the next list, which is the bottommost list. And once again, 20 is greater than 10 but is lesser than 40, so it must be placed between 10 and 40, and that's why it is placed there. We gave it a coin flip of 1-0, which means that it must be placed in one more list before the coin flip is a 0, and with that is why it is also added to the next to bottom list. For deleting 5, we once again begin at the very top node, which is 10. 5 is less than 10, so it is realized that 5, if present, is going to be present in the left subtree of 10. And that is the first node that we hit as soon as you go into the left subtree, and so it is deleted from that point. And 5 does not have any children trees, and because of that, there is no other modification that we need to make to these trees. For removing 5, we begin with the first list, which is once again empty. The second, which has in which 5 is between the bounds of negative infinity and 10, and then we moved on to the bottommost list, and that had negative infinity, and then the next value that it runs into is a 5, and so the 5 must be deleted. It is not present in any of the upper lists, so 5 is just removed, and that is the modification that is made to the skip list. While looking for 80, which is what we are attempting to do in this specific instance, we go through the same cases. It goes to the first node, which is 10. 80 is greater than 10, so it must be in the right subtree. It goes to 40. 80 is greater than 40, so once again must be present in 40's right subtree. And then it hits the next node, which is 80. And since 80 is the key value that we're looking for, it has been found. In the skip list, in the very first list that we traverse, what happens is that 80 is greater than negative infinity as well as 50, but less than positive infinity. So using that information, we go into the second list. Once again, it is greater than 50, but lesser than 100. So with that brings us to the last list, the very bottom list, and it is once again greater than 50 and lesser than 100, and there are no other elements present there, so it must be added between 50 and 100, must be found between 50 and 100, and that is where it is, so AD is found. Thank you so much. I hope this was informational.